So now we have flash point. Flash point is the minimum temperature at which a liquid fuel gives off enough vapors to form an ignitable mixture with air near the surface. So, flash point. Flammable and combustible liquids themselves do not burn. It is the mixture of vapors and air that burns. So, for example, if you're ever pumping gas into your tank, you see the fumes and you can smell the fumes. Those are the fumes that ignite when gasoline is caught on fire. So if I were to throw a straight line of gasoline on fire, you could see the flames, but you couldn't see the gasoline itself burning. Gasoline with a flash point of negative 40 degrees Celsius is a flammable liquid. Even at temperatures as low as negative 40 degrees Celsius, it gives off enough vapor to form a burnable mixture in the air. Phenol is a combustible liquid. It has a flash point of 79 degrees Celsius, so it must be heated above that temperature before it can ignite in the air. And that's very important when talking about dealing with hazardous material fires and stuff like that, because you don't want to die, or you want to conserve life and keep the incident stabilized and conserve property. Some key terms. So some key terms are fire point, the temperature at which a liquid fuel will produce enough vapors to support combustion once ignited. Ignition temperature, the minimum temperature to which a fuel in the air must be heated in order to start self-sustained combustion independent of the heating source. So this is very important when talking about, water ignition temperature, paper ignition temperature, and, rubber. So paper against rubber, paper's going to have a lower ignition temperature because it's so thick or so thin, while rubber may have a higher ignition temperature because it takes so long to burn. Rollover. Rollover is when flames move through the unburned gases during a fire's progression. So, for example, if we're in the growth stage of a fire and heavy smoke's hitting the ceiling, continues to hit the ceiling, fire is going to start trying to ignite those gases, and you're going to see a little flicker. This is an example of rollover. So this is very important when talking about backdraft and also flashover. So as you can see in this picture, the smoke is catching on fire, right? And it's not the appliance right here is burning itself, but as you can see, the smoke is catching on fire because of all the unburned gases. So another key term is the critical flow rate, the minimum flow in a gallon per minute needed to extinguish a give fire. So this is talking about how much water the engines pump into the fire. This is very important for engineers to know because this is what helps the firefighters out fighting the fire. Thermal layering, a tendency of heated gases with a given area to rise and stratify. And that's it. So before I end this, I would like everybody to know the importance of fire behavior. It's very important to know about fire behavior because it can conserve life and conserve property, and everybody should know it because if you extinguish the fire before you have to call it in or whatever, it saves a lot of time and a lot of energy. So therefore, people need to study on these things.